Hi, my name is Sean Curtin. For my Calculus 3 project, I chose functions of two variables and surfaces. I chose this topic because it is the backbone of multivariable calculus, which helps us model 3D surfaces like terrain, airflow, and engineering designs. This project satisfies the requirements by covering the core concepts of the chapter, such as domains, level curves, and real-world applications. To visualize these ideas, I graphed functions in Python, which included simple planes and more complex shapes, such as paraboloids and saddle surfaces. Being able to see the changes in the function of the graph gives a deeper understanding to the concepts. I also included level curves similar to topographical maps, which show how we can condense a 3D surface into a 2D contour. Finally, I did a NACA 2412 airfoil, which is a great example to be able to show how functions are used to be able to design efficient wings. My project shows how multivariable functions create 3D surfaces, with real-world applications like wildlife researchers studying mountain goats. Picture this, a team is given a 3D map of a mountain, but they only need to focus on where the goats live, between 1,500 and 4,000 meters in elevation. That range becomes the domain of their function, setting clear boundaries for their research. Level curves then simplify the 3D terrain into 2D contours, like those on a hiking map, making it easier to spot elevation changes at a glance. And it doesn't stop there. Gradients, which come from partial derivatives, optimize designs for things like airplane wings, where small tweaks to the curve can dramatically improve performance. These tools aren't just abstract math, they're practical problem solvers, whether you're tracking goats or engineering the next generation of aircraft. This project changed how I see calculus. Before, multivariable functions felt like abstract equations, but now I recognize them everywhere, from the curves of airplane wings to the way weather patterns move across a map. Working through real examples like the mountain goat habitat and airfoil design helped me understand why we learn these concepts in class. I also gained practical skills like creating 3D graphs in Python, which showed me how powerful coding can be for visualizing complex math. Most importantly, I learned that calculus isn't just about solving problems on paper. It's a toolkit for understanding and improving the world around us. Thank you for listening to me talk about my Calculus 3 project.